Hi dear students, let's see this question that came in JEE Advanced Paper-1 Physics in the year 2019. This question was based on verification of Ohm's law, and it had slight amount of calculation, although not much. But I believe that most of the students would have found this easy. It was based on multiple choice correct question. Hence, if you get all the options right, you get +4, and for any wrong answer or any wrong option if you choose, you get -2, and you get partial marks as well. So let's quickly see what is given over here. There are two identical galvanometers, both of which have 10 ohm resistance, and the full scale deflection current is 2 microamperes. One of them is converted into voltmeters of maximum range 100 millivolts, and other is converted into an ammeter of range 1 milliampere. We are trying to measure a resistance of 1000 ohm using this setup, and then we have to comment upon the values of the resistance of the voltmeter, ammeter, and other things that we will eventually see. So basically, first let us find out the resistance of the voltmeter and the ammeter that will be created. As you can see, that has been asked specifically in option A and B, right? So now if you try to recall that how do we create a voltmeter? So basically, if this is a galvanometer, we attach a very high resistance over here, okay, and this circuit is called as this whole thing is called as voltmeter, and the maximum scale deflection current, which we call IG, is passed through it. So if this whole thing is voltmeter, galvanometer itself has a resistance of 10 ohms. So we can say this total thing is called resistance of the voltmeter. So we can say that IG into RV. Now you should realize that RV is nothing but 10 plus R dash. So this is the reading of the voltmeter, which is given as 100 millivolts. So 100 into 10 to the power minus 3. IG was given as 2 into 10 to the power minus 6, right? So this will become like this. Okay. So RB comes out to be, this will become 1 lakh by 2, 50,000. 50,000 ohms is the resistance of the voltmeter. Okay. This makes option A wrong because it is given 1 lakh. Now let's talk about the resistance of the ammeter. If we talk about the resistance of the ammeter, so basically if you try to recall how is ammeter connected, so this is a galvanometer, okay, and we create, like, we attach a very small resistance which is called as shunt, and this whole thing, remember galvanometer itself has a resistance of 10 ohms. This whole thing is called as ammeter. Okay, so if current I, which is the maximum current that this ammeter can measure, so this I current comes here, so this IG current will go here, and remaining I minus IG current will go here. Okay, so if you see, the value of I was 1 milliampere, so we can we can equate the potential difference. This 1 milliampere is 10 to the power minus 3 minus IG. IG is basically 2 into 10 to the power minus 6. So this is the current going in the shunt, multiplied by shunt will be is equals to potential difference across galvanometer, which is IG, which is 2 into 10 to the power minus 6 into 10, right? We multiply whole equation by 10 to the power 6. So if we multiply this whole equation by 10 to the power 6, so it will become 1000 minus 2, which is 998, into shunt, which will be equals to 20. So value of shunt comes out to be 20 upon 998. Mind you, this is not the resistance of the ammeter, because try to recall that this whole thing is called ammeter, not the shunt. So this whole thing, as a, if you try to find the resistance of the ammeter, so this whole thing will have a resistance S into 10 divided by S into S plus 10, right? So this becomes 20 upon 998 into 10 divided by 20 upon 998 plus 10, right? So if you take the LCM, 998 will be cancelled out, and it is easy to see that in the denominator you will get 10,000. So the numerator it will be 200 and divide by 10,000. So this is 0.02. So option B is correct. Now, one interesting thing that you will observe over here is, if you round off to second place decimal, they have IITs has given this, but if you see, we are getting exact answer 0.02. So what might have been the reason for that? See, ideally, if you have prepared for JEE, then you would realize that most of the times we take an assumption that in front of 10 to the power minus 3, we can ignore this quantity. So if you ignore this quantity 10 to the in front of this, so basically the shunt value will be slightly different from this, and overall ammeter resistance will be slightly different from this. In fact, you're going to get some values on the third or fourth decimal, which when rounded off to second place decimal will again become 0.02. So probably that was the reason IIT gave that assumption. But the good thing was that in this case, if you don't make an assumption, then the calculations will also be easy and you will not have to make any approximation. So one peculiar case where doing exact calculation is rather easy and also error free, although most of the times it's always other way around. So option B was right. Now let's go back to checking other two options. If the ideal cell is replaced by cell having internal resistance of 5 ohms, then the measured value of R will be this, the measured value of R. So now we have to find the measured value of R. So if you recall, what is the circuit? So basically, if this is the external resistor R, so basically what do? We apply a voltmeter over here, which measures the potential difference across the resistance, and the ammeter measures the current flowing in the circuit, and this is the battery which is of EMF E naught, let us say. So ideally, when a student is performing this experiment, what is he going to do? He is going to see the reading of the voltmeter, which is V, and see the reading of the ammeter, which is current flowing in the circuit. Let's call that I for the time being. And he would believe that this V is actually E naught, assuming this to be, if the V is ideal, so in that case, V will actually become E naught. So, and the current flowing in the ammeter will be seen by the reading, and he will do V by I. That means reading of voltmeter divided by reading of ammeter. Correct. So the measured value of R, which is we can say R, value of this R, will be nothing but voltmeter reading divided by ammeter reading. Right. Now, if you see this voltmeter reading is the potential difference across these 2 points, because the it will not be E naught in this case because our voltmeter is not ideal. So this is the potential difference across these 2 points, which is the reading of the voltmeter. This reading can also be written as E naught minus I into resistance of ammeter, right? Because the potential drop across ammeter will be IRA. So this potential difference can be written as E naught minus IRA, right? And reading of ammeter will be this current I itself. So if you see, this becomes E naught by I minus RA. Now, E naught by I is the current flowing in the circuit and E naught is the battery EMF. So this itself is the R equivalent of the circuit, which like E naught by I will be the R equivalent of the circuit. So if you see the R equivalent of the circuit, that will be R in this, these two resistors will be in parallel, and with that RA will be in the series. So R into RV divided by R plus RV plus RA. This is the R equivalent, and minus RA was already present. So these will cancel out, and the value will become RRV divided by R plus RV. So this will be the measured value. So let's call this R dash. R dash is the measured value. So R dash will become R is 1000, RV I believe was 50,000, divide by 50 plus 1, 51,000. So this will be gone. If you solve this value, it will be slightly, you will get 980.2 approximately, which matches with the option D. Now let's talk about option C. If the ideal cell is replaced by a cell having internal resistance of 5 ohms, then the measured value of R will be more than 1000 ohms. Now, it is very obvious to see, suppose I attach a 5 ohm resistor here. Then let's see what will happen in this calculation. Again, the value of R dash will be found out by the same method, reading of voltmeter divided by reading of ammeter. Reading of voltmeter now can be written as E naught minus IRA minus 5 into I. So this thing you can see will become E naught minus IRA minus 5 into I, right, divided by I, right? So this becomes E naught by I, okay, minus RA minus 5. This again is R equivalent of the circuit. So R equivalent of the circuit will become RRV divided by R plus RV plus RA plus 5, which will be cancelled out by this value, right? Plus RA plus 5 will be cancelled out by this value. So again, you see that value of R dash has not changed even if we put any resistor over here, and hence there will be no change in the value of measured value of R dash rather. So option C is wrong, and hence option B and D will be the correct answer. I hope you would have enjoyed this solution. And as I said, the question was not easy, but yes, slightly calculated. Thank you.